Okay, folks, let's continue on from yesterday. Yesterday's video, we were mixing our factoring. We're just going to continue on with that and move to solving using that method as well, that mixed factoring idea. So, just kind of review and touching on that again. Here we've got a couple problems to factor. And remember, over there on the right-hand side, GCF first, okay? Always start there. Look for any GCF you can pull out, including just a negative, okay? If there's a negative you can pull that out. And once you're done with the GCF method, if it happens to be a trinomial, if there's three terms there, check and see if it's set up as a trinomial you can factor. In other words, the first term is an x squared with nothing else in front of it. The second term is some kind of x term, and then there's a constant. If it looks like that, then try that method of two magic numbers that multiply to the last and add to that middle coefficient. See if that'll also work. You just got to check through this list as you factor. Let's do it. Okay, that's clearly a trinomial. That right there looks perfect for me to try a trinomial method on, but we have to notice that is an issue. Can't have that negative up front, which means I need to factor that out. You're always allowed to factor out a negative because there's always a sign you can change on each of the terms. So I'm going to factor out a negative 1. All that means is flip the signs on everything in that trinomial. So that negative x squared is now positive, negative 3x becomes positive 3x, and the plus 18 becomes minus 18. Now at this point, once that's out, what remains is something that looks like a trinomial I could factor. So I'm going to try that method now. What's going to multiply for our negative 18 and add to a 3? I'm immediately thinking a 6 and a 3. And putting those together to make a positive 3, and also recognizing it's a negative 18 they multiply to. So I know their signs have to be mixed. So I know it's going to be a 6 and 3 with mixed signs. And since they're adding to a positive 3, the bigger number, the 6, needs to also be positive to make the addition work. So there we go. And then last, don't forget that negative 1 we factored out. So that is a factored quadratic, all the way factored down. Okay, number 2, let's do the same thing again. It's trinomial. So maybe our trinomial method will work, but first we've got to try and pull out any common factors to all of those. There isn't an x on this last term, so we don't have to worry about variables. There are no common variables. We're just going to try to pull out a common number out of those coefficients. And I'm just going to automatically start with that negative 3, because if I can pull out a negative 3, it then becomes x squared on the front, and maybe my trinomial method works. So we're just going to start with a negative 3, see if that works. I just look at each of these terms. 42, can I divide a 3 out of a 42? Yes, I can. That's 14 times 3. And then 45, that's 15 times 3. Sweet. So there is a common 3 that all of them can pull out. 14 is left in the middle term. 15 is left on that last term. And notice also, since we pulled out the negative, that's going to flip all of their signs. So that negative 42 when it becomes 14 is positive because the sign was also taken and factored out. Plus 45 becomes minus 15. And now, and you guys gotta watch me. Did you catch that mistake earlier? I'm not sure why I made that a cubed. I did that on last night's video too. It should be an x squared. And then I gotta bring down my x. I'm in such a hurry to finish factoring, I'm missing my details. Now notice what's left looks perfect to try our trinomial method. So again, factors for 15 that are going to add to that 14. A 3 and a 5, there's no way they're going to make a 14, so I'm going to try 1 and 15. And since it's a negative 15, the signs have to be mixed, and when they subtract as mixed, that will make a 14. So that's my pair. There's my x's, and since it's positive 14, it needs to be positive 15 that adds, and negative 1. those work. Those add to the 14. Don't forget my -3 up front that I GCF pulled out. And there we go, factored, okay? So that's just more review from yesterday. Let's apply that here with a little bit of extra, and then we're going to have you practicing this stuff. Let's also solve this. So when we solve, remember number one, and we've been talking about this for a couple of days, couple of videos and classes already, your equation must equal 0. And that has to be done before you start, because you factor everything on that whole left side of the equation, in this case left, and if it's not equal to 0, some of the value on the other side is part of the factoring process, and you've left that constant out. It needs to be moved over and zeroed out on the right, so you've got everything to use. So in this case, we're good to go. Step 1, we're good. It is an equation equal to 0. So then next, always try GCF. That's already what we've been saying. We just did that on the last page. And this one, notice, only has 2 terms. So GCF is all that's going to work here. We don't have to worry about trinomial form, so we're just going to ignore that third step. Let's go ahead and just use our GCF method and factor it. Okay, if I use a factor tree, I see I can pull a 2 out of both of those. And what'll be left is the 4 out of the 8 and the 7 out of the 14. I'm going to copy down that negative between them. 4 and 7 don't have another common factor, so I'm good to go there. And then as far as my variables, x squared and x, I can pull 1x out, and that leaves 1x inside out of the squared. And that's factored. So at this point, we've been stopping there with our GCF factoring, but now we can also solve them if we can GCF factor them down. And this is with this current unit is quadratics, remember? Quadratics are all the equations where your x is squared. The highest exponent is x squared. So that's what we're focusing on right now, is the quadratic type equations with an x squared. And if you have a quadratic that looks like this, an x squared in the front and an x in the middle term, we end up splitting them apart when we factor, which means we can solve this guy. We now have 2 x's just raised to a single power, so we can solve it like we would solve the trinomial ones we've been doing. So now since the 2x is multiplying with the 4x minus 7, it's exactly the same idea as before. Those two things multiplying equals 0 tells us that either that 2x term must equal 0, or the 4x minus 7 term must equal 0. Notice, we're doing exactly what we did with trinomial. We're just splitting it. If that whole thing equals 0, then it's factored form. Each piece that's multiplying, each of those can also be set to 0. Which means we can just go ahead and solve it. Okay, 2x equals 0. Now think about that for a sec. You really don't have to do any work. What times 2 is going to make 0? The only thing that works there is 0. So it turns out that x could be 0. And then we solve the other side. That's just a 2-step equation. Okay, we're going to have to remember back how to solve your equations. You're going to get stuck here. Cancel off that constant with the plus 7. Divide off the 4. And it's going to end up as a fraction. That's okay. You can handle that. And so there are our 2 solutions to this quadratic. X equals 0 or x equals 7/4. And if you think about it, remember solutions are the same as x-intercepts. So we could even sketch a graph of this. We could say, well, 0 on the x-axis we'll say is there. 7/4 is a little over 1.5. So if I was going to take a guess, about right there. And since the front term is positive on this quadratic, that tells us it's upward. So I could basically sketch that parabola. And there you go. My 2 solutions are shown on that graph, or we factored and solved, and they're right there. Same thing, either way. I'm hoping this is connecting dots. Graphing pun intended there. Okay. Let's just do it again. I know there's a lot going on here. I'll do it all one more time. Nothing new now. I'm just going to walk through it again. bring our instructions down too, that's handy. Okay, so if we look at this again, the first thing to remember, and this is what we haven't seen yet, make sure you do this. The equation, start here, must equal, oops, we lost some of our words, must equal 0 before we start. That's important. Notice here, this guy doesn't equal 0, so we need to move that piece of the constant, that last term, that -8, needs to get canceled off and moved. And we've already done this before. This is something we have experience with. We just add 8. If I need to cancel off that -8, I add 8, it zeroes out. Add 8 to the 7 right next door. Now the equation equals 0, and notice it's not a +7 at the end of the trinomial, it's a +15. That totally changes how you'll be able to factor that. That's why we have to set it equal to 0 first, okay? So first thing, just set them to 0, and now apply what you already know. Try for a GCF. Well, actually, I don't even think we need to, because I look at this x squared, there's nothing up front on the x squared. This looks like it's trinomial, and it's ready to go trinomial form. So I'm just going to go that route. 5 and 3 seems perfect, and if I use -5 and 3, they'll add to that -8 that I need, so it looks pretty straightforward. X minus 5, x minus 3, and from here on out, you guys know how to do this one. There's my factored form. Flip the sign. There's my solved form, so there's factored. And then right there, step 4, don't forget to solve it, and there is my solved form. Okay, so we've got factored and then solved on number 2. And if we went right back up to the original here, we've got the same thing. Factored form is right here. We GCF factored, and then one step further, and there's our solved. Okay, so the two things I want you guys to grab right now is when you do your GCF factoring, you can also solve that way. Just make sure the equation equals 0, factor it, set each piece equal to 0, and you can solve. And then number 2, make sure you set that equation equal to 0 before you start, because that changes the numbers you use to do your factoring. All right, here's a set of we try problems, okay? Same things we've been doing. There's your instructions, your 1, 2, 3 over on the right. So you work these out with me coaching, and I'll go behind after, but you really need the practice right now. So first off, anytime you're looking to solve something, or even factor it for that matter, if it's a finished equation, it's got to equal 0. Your number 1 does not equal 0, so you need to move that 24 over. It needs to be canceled, and just move it to the other side. And notice, there isn't a constant on the other side to add or subtract that 24 with, so it'll just plug right in at the end of that trinomial, okay? So how do you cancel a 24? Do the same to the other side. You're just moving it across to the other side of the equation. All right. After that, do you need to try for a GCF? Or is it a trinomial form that's already ready to go with? Make your choice there. And then try trinomial factoring and solve it. Okay. Finish that one. Go ahead and pause until you're done with number 1. All right, let's see if you're on track. We need to cancel that off by just doing a -24 to cancel it. So when we rewrite it to make sure it's set equal to 0, it's just going to be a -24 on the other side, because we've done a -24 on both sides. You can think of it that way. And there's nothing to actually subtract the -24 with, so it just becomes -24 on the other side, but now it equals 0. And at this point, I think either you've got trinomial factoring or you're going to need more help than me repeating it. I'm going to look at the 24 and say 12 and 2 are probably my numbers. That's the worst x ever. And they're going to be mixed sign. I need the 12 to be positive to make the 10 work. There you go. And if that is my factored form, it's really easy for the final to jump to the solved form. X is going to equal negative 12, and x is going to equal positive 2. Now, just to put some dots together for you later, again, remember, if we were to graph the quadratic, anytime the very front of your quadratic up there, the x squared term is positive, that tells you it's going to be an upward parabola. So I would have an x at negative 12 and an x at 2. So if I go way out to negative 12 and put a dot, go out to 2 and put another dot, and it's going upward, it's going to be a big parabola, probably going really far below because it's so spread out. And so there you go. Just to help you with that concept, there's my solutions, both on the graph and if I factored it to solve. All right, number 2, let's walk through number 2. Okay, start by getting it set equal to 0, which we can see it is. Try for GCF and look for trinomial. Clearly we don't need to worry about trinomial. There's only 2 terms here. So you're going to factor it, and then you're going to set each equal to 0 so you can finish solving it. Go ahead. Okay, pause it if you need to, and then unpause when you're done. Okay, let's jump in here. I'm just going to look for a GCF at this point. 14 and 8. Boy, 2 seems to be the only thing I'm using lately. And 7 and 4. Holy cow. How many times have I used this problem lately? That's hilarious. Now, notice there's a set of negatives. At this point, you can go either route, and it won't affect our answer. You can have the negatives factored out onto the 2. You can leave them inside with the 7 and the 4. It's going to work out okay either way. I'm going to pull out the negatives onto the front. When both terms are negative, I think it's better to pull it out. Then you get rid of that pair of negatives. There's just that one negative now on that front factor you pulled out. And then as far as x's, if there's 2 x's on the front term, 1 on the back, that gives me 1 to pull out, 1 left on the 7. And you notice this is kind of formulaic. You're seeing the same thing. That's how it'll look with quadratics, because this is how a quadratic is going to be written if it's only got 2 terms. X squared in the front with an x on the second term, if that's the way it's written. They can be written in various ways, but this type is fairly formulaic. It'll look like this if you can GCF factor it. Now we'll split it up. Either the negative 2x is the solution equal to 0, or the 7x plus 4 is. You just set them both equal to 0. You call them both your solutions, and then solve them. And again, minus off the 4 this time. Divide off that 7. So the x equals negative 4/7. Or, we can see again here, whether you do the dividing or you can just see it, the only thing that's going to multiply and create 0 is 0. 0 divided by anything equals 0. So there you go. There's our 2 solutions. All right, here's your homework for today. Practice homework problems. Now, these are challenging. Well, I shouldn't say that. I'll intimidate you. These aren't any harder than what I've done already, and I've got the instructions right there. So you could really say they're easy, but they do require you to be thinking. I'm going to walk through them with you for that reason, okay? Number 1, I'm going to put the solutions up. I'll solve these after you're done, but you need to be walking through them. So let's just talk about them together. You can work through them as we go. Number 1, we're going to look at it, and right there, equation must equal 0. Okay, if we start with step 1 there, he doesn't. So you need to move over that 24x. Okay, so the whole equation equals 0, and then we'll have only 2 terms, and you can use your GCF to factor that. Look for what you can pull out of those coefficients. What can you divide out? What can you take out of the x squared and the x? And then once it's solved, set each to 0, and then you can, once it's factored, set each to 0, and then you can solve it, okay? So pause it and do number 1 now. Go. Okay, I'm going to minus that 24x over, and hopefully you guys will also remember that shortcut. I'll do it out here. Just copy that. And to move anything over to the other side of an equation is just to flip its sign. So the 24x will become negative 24x. And we can see here, we would just be minusing a 24x on the other side. And that sets it equal to 0. We canceled everything on the right. Now, once we've done that, it's two terms, and I'm going to factor. The x squared and the x, I'll start there on this one. I can pull an x out, leaving an x on that front term. I'm going to copy down the signs so I don't forget. And you know what? They're both negative. So I'm going to factor the negative out as well, which means they're now both positives. Now I just look at my 32 and my 24, and I think, what can I pull out of both of those? I'm going to guess an 8. 32 is 8 times 4, 24 is 8 times 3. Yep, 8 is something I want to pull out, so I'll pull that out. Leaving a 4 up front, leaving a 3 in the second term. It still equals 0. And there we go. That's my factored problem. So now to finish it, I just set each equal to 0. And are you noticing the pattern, guys? If I set that GCF, anytime the GCF is set equal to 0, it's always something that's just one term multiplied. So it's always going to be that x equals 0 when you do GCF. That front term, x is going to equal 0. That's the only thing that can cancel out whatever's with x. And then the second one is often going to be a two-step equation you solve. Minus over the 3, and divide off that 4. There you go. There's my factored and then solutions to number 1. All right, I'm going to erase that. You can go back in the video if you need to get that, but it's in the way. So that one's gone. You've got it in the video if need be. Let's look at number 2. Sure, we'll just do that. Moving number 2 up, let's do the same thing. Look at number 2, and what do you need to do first? Walk down your steps. We're going to factor and solve, set it equal to 0. Look for a GCF, including just getting a negative out, taking out a sign. Okay, remember you can't have a negative on the front of your x squared. So there you go. I kind of gave you everything you need. Finish and factor solve number 2. Pause and go. Okay, I'm going to jump in here. You should be done. To move over that 36 is to subtract it off and cancel it, which means it becomes negative 36 on the other side. So now it's equal to 0. And I've got to factor out the negative 1. Now it's going to be in trinomial form once I flip all those signs. Okay, so number 1, good. Number 2, yep, got rid of that negative. Now number 3, I'm going to work on my trinomial. I'm just going to think, what can I break that 36 into that's going to add to a 12? That one looks pretty obvious. I bet 6 and 6. They'll both be negative 6s. There we go. And don't forget the negative 1. Now, notice when we get to this point, we are going to split up and set each of these equal to 0. But the GCF doesn't need to be split off and equal to 0 on this problem because there's no x up there. You could technically do this when you set all 3 pieces equal to 0. Notice I just took all 3 pieces that are multiplying and set all 3 parts equal to 0. The GCF and each of the binomials. There's no x here. It just makes a false equation. There's no point. So you actually, when you get to the solution part of this, you can just ignore and cancel off that GCF. All we care about is the 2 x's. Now, I shouldn't erase that for the sake that this is your factored form. If you're asked to factor this, it needs to look like that. But once we go to solution, you only need the pieces that have an x. We're going to flip that sign so we can see that x equals 6 for both. There you go. And by the way, if we were to graph that, do it that way. If we were to graph that, since there's technically one solution, the same number twice, it tells us this. it was a negative up front, so it's going to be a downward parabola. And because our solution was only one number, we came to the same number both times, it tells us that it only hits right at x equals 6, which means that's the vertex. And that's what the parabolas look like when there's one solution. So we know our vertex is right at 6. We know our axis of symmetry is right at 6 because we got that single solution right at the vertex. All right, let's do number 3. We're going to get rid of all this to make room for 3. You've got the video if you need to look it back up. Okay, look at number 3 for a sec. You're starting to get the hang of this. What would you need to do? I bet you're telling me I got to set it equal to 0. Good. Get rid of that 8. Minus it over. So the actual equation we need to try and factor is that. And now we look for what? Yep, I heard somebody say GCF. Good. So can I take anything out of all 3 of those? Probably you should be saying no. 11 is prime. Nothing comes out of 11 but 11 and 1, which tells me I can't factor this, which tells me number 3, if you remember like yesterday's video, is unfactorable with what we know so far. So we need another method if we're going to solve this guy. And that method is the quadratic formula. That's what we're going to learn tomorrow. And this is why we're going to learn it, because sometimes we can't do a factoring approach. We need the quadratic. So number 3 is as far as we can go for now. We'll have to revisit him another day. All right. Number 4. Let's look at our final. Okay, looking through number 4, I'm going to stop for a second and let you do what you need to do at first. Do step 1, do step 2, do step 3, do step 4. Go. I'll come behind you and finish it in a minute. See if you can do this one on your own. Pause it. All right. I know it's got to be set equal to 0, so first thing I'm doing is moving over that 14. So it's not actually a negative 40. It looks like it's a negative 54 that's going to equal. And the whole equation equals 0 now. I'm just going to copy over those pieces of that. Okay, so now that's the equation I'm actually going to work with. And clearly I want to try and pull out a GCF of a 2 so I can get it and see if that trinomial form can be further factored. So if I pull out a 2, I just need to look. Can these 2 coefficients be divided by 2? And yes, they can. So I'm just going to copy down the sign. And then a 12 divided by 2 leaves us 6x. A 54 divided by 2 leaves 27. Okay, so we've got it equal to 0, and we pulled out a GCF. Now I'm going to see if I can also trinomial factor the inside. The goal is always to try and break down that x squared into just x. Once we do that, then we can finish and solve. We really got to break down those x squareds. That's always our goal. So 27, I'm thinking 9 and 3. And yes, if I make mixed signs and make the 9 negative, that will add to the negative 6 and multiply to the negative 27. So there we go. And the GCF there. So there we go. There's my factored form. Now if I'm going to finish, this will go up. If I'm going to finish and solve, at this point, there's factored form, but I don't need that GCF anymore. I just need the 9, x minus 9, and the x plus 3. So to solve, I'd set each of those equal to 0, and it tells me my 2 solutions are 9 and negative 3. There's factored, and then there's solutions. All right. If you got through that on your own, give yourself a pat on the back. You're putting together some skill sets. Good work. See you tomorrow.